All right, in this video, we're going to talk about how to write a radical as a pure imaginary number. Um, these are instructor created problems, so you won't find them anywhere in your textbook. Um, so I won't write down problem numbers here. But when we talk about a complex number, let's talk about what that is first, because that's the big idea of what we're going to be talking about in the next few videos. A complex number is a number that has two parts to it. I'm just going to say plus here because this is going to be the real part, and this is going to be the imaginary part. Where the number I is equal to the square root of -1. We've talked a lot in other videos about how we can't take the square root of a negative number and get a real number. So we are going to first, in this video, just talk about numbers that will only come out with an imaginary part. So we're only going to be talking about this part of a complex number where this real part is 0, and we're going to call this part, if there's no real part over here other than 0, we're going to call this a pure imaginary number if it's just in the form of bi. B can be positive or negative, so we're going to see some negative imaginary numbers and some positive imaginary numbers. We'll get lots of practice with complex numbers, so if that looked a little confusing, don't worry about it too much. I think it'll make some more sense after we do several examples here. First thing that we need to do here is that this negative that's inside the square root, we need to just peel that off as the square root of -1, and we need to deal with the other part in there, the square root of 25, like we normally would. So the square root of 25 is 5, and we're going to call the square root of -1i, and our pure imaginary number here is going to be 5i. Now we're going to have a negative root of -144. So leave that negative outside. We have a 144 inside this root and a root of -1 there. So this can be a negative root 144 is 12. And there we go. Just like with all other roots, we can have some leftover parts inside the square root sign. So that's what we're going to see in our next example. So we're going to pull out that -1 there. We have a root 28. 28 does have a perfect square of 4. So we're going to have I like writing my I out front of the square root part that's left over, just so it's clear it's on the outside and not the inside. But most textbooks and software applications want you to write the I last. So they would want you to write this as 2 times the square root of 7. You'd have to be very careful to put some space here, not space, but to make sure that you're outside of your square root sign before you write your I. It's very different to have the I inside the square root sign than outside the square root sign. All right. Now we have the square root of -6. It's going to be the square root of 6 times the square root of -1. Square root of 6 doesn't break down anymore, so that's square root of 6i. Again, be careful that you make sure that that I is on the outside. We have the square root of a negative 49, which is root 49 times root negative 1 is a 7i. Did we do that one already? No, we didn't. Root negative 14 is root 14 times root negative 1. That one doesn't break down anymore, so that's root 14i. That's the one that we did already. So now we have root negative 252. It's going to be root 252 times root negative 1. So let's look at 252. See what it breaks down into. That's 2 and 1, 26, which is 2 and 63, which is 3 and 21, which is 3 and 7. So I have a pair of 3s, a pair of 2s that can come out as a 6. So this is 6 root 7 and an I on the end. Negative root negative 100 is negative root 100 times root negative 1 is negative 10i. Negative root 50 is negative, sorry, write that backwards. Root negative 50 is root 50 times root negative 1. It's going to be 25 times 2 is root 25. Root 2 negative 1 is 5 root 2 I. Negative 3, be root 3 times root negative 1. It's going to be root 3 times I. That's going to be it for this video, where we have written these radicals as with a negative on the inside as pure imaginary numbers. When we come back in the next video, we will write expressions as complex numbers in that standard form of a plus bi, like I talked about in the beginning of this video. We'll just have a couple examples of that. So see you for the next video.